You ready? You ready? You ready? Ready? All right, class. Y'all suck. Forget you all.
Did you upload that video?
I don't know what you're talking about. So, all right, for those few people that actually want to learn and not play on their phone the whole time.
I want to look for that video. I'll look for it on your class.
Okay. All right. All right. You're gonna like take the clip and like remix the whole thing, right? You're gonna. Okay. Anyway. All right. So for those people that came here to learn and to try to graduate, thank you. Other than that, was it Clash Royale has a new update? So go ahead and just work on that. Okay. Anyway, notice how I'm like trying to talk crap to people that are just playing on their phone and not doing what they're supposed to be doing. Fired. Right? Okay. Good. All right, vectors, operations, and the dot product. So, anyone actually take physics? Yeah, a lot of the stuff is similar. But this is easy. All right, scalar. Magnitude of a quantity can be represented by a real number. Vector. In the plane is called a directed line segment. Consider vector would be OP, like this. It starts at O, goes through P. O is called the initial point, P is the terminal point, or the ending. Magnitude of a vector expressed as bam, bam. See those absolute value bars? Okay, that's referred to as the magnitude. Two vectors are equal if and only if they have the same magnitude and same direction. Now, same magnitude, same direction. Now, are these going the same direction? Okay, opposite directions. So these ones are not the same. Same magnitude though, but opposite direction. So look closely at the way that it's lettering. So A is equal to B, C is equal to D, A not equal to E, because they're not going in the same direction. A, going this way, is not equal to F because they're not the same length. Make sense? Good. Sum of two vectors is also a vector. Their sum, A and B, is called a resultant. Two ways to represent the sum. You draw it out. Now, I do this as if we're walking from one place to another. Sum of that vector V and its opposite negative V has a magnitude of 0 because called zero vector. So if we subtract vector B from A, find that sum of A plus negative B, you should get 0. So as the two go together, you should end up with 0 there. So since we have one going one way, the other going the other way, they will cancel each other out. Scalar product is a real number k and a vector u is the vector k times u. So see this right here, we have u. Okay, 2u would be how much longer? 2 times u. Very good, right? All right, super easy. All right, what about 3/2 u? Yeah. And if I have any other fraction, anything less than 1, it's going to make it shrink. It's going to condense it. And then my last thing I have right here is if it's a negative, it goes in the opposite direction. All right? A vector with its initial point and the origin is called a position vector. So origin is on my coordinate plane, right about there. Ah, dang it. Oh, do this stupid thing. Anyway, so we're going to start a lot of these in this, and it's going to end up at the coordinate there. Now, think about this. How far is Douche Bros from here? It's like half a mile that way, right? Okay. So basically, we're saying you're going to go half a mile that way. So that's going to be your vector. It's going to give you your directions to get there, and it's going to say that way, and your magnitude is the distance. But if I was talking about, so this is my vector of that, or we could say the coordinate, help me out, coordinate C, is it OO? I have no clue. You guys know I suck at this. Anyway, all right, so instead, the coordinate for this would be, it is going to be, I don't know, what's the address, like 2301, like North 7th Ave. This would be the coordinate here, where the vector is me giving you directions to go from here to there. We could tell the difference in between a vector. Vector has these little, instead of parentheses. Thank you, man. My coffee's only half empty. All right, so we got these. So this is going to tell me that this is actually going to be a vector, and if they're just regular parentheses here, that's going to be my coordinate. Numbers A and B are the horizontal component and the vertical component. Okay, A and B, there's my coordinate. So that means I went in the direction of A, right? And from there, I went from the direction B. So I have two vectors going together, so that's where I can get from A to B. And U is going to be the magnitude from there. Magnitude, length of vector U, AB, given by this. Remember, those absolute value bars are not absolute value bars. It's a symbol signifying that is going to be the absolute value of that. Now, can anyone tell me what this thing looks a whole lot like? There we go, Pythagorean theorem, right? So if it is the Pythagorean theorem, we know that it's dealing with the right angle, right? And it's going to be A, B, C. So it's A squared plus B squared equals C squared. So if I want to try and find the value of C, which is going to give me that value there, I would square root both sides. So squared plus B squared equals of C. So looks a whole lot like this, right? We've been doing this whole year, all the time. Now we're just trying to do it in a different way, or just calling it something else. Now, when we get to this right here, I'm going to cross that out. I'm going to cross out that formula because that formula sucks. I hate it. So we're going to make it easier. Find the magnitude here. Okay. So my magnitude, they gave it to me U, right? Let's plug this in. U is equal to the square root of what? Which is, what's A in this case? 3, right? Okay, so it's 3 squared plus -2. But now when you put -2, put in parentheses, because when we square it, we have to include the negative, right? Good. So 3 squared is 9, 2 squared is 4, 9 and 4 gives me 13. So we get U is equal to the square root of 13. Is that pretty easy so far? Okay, so let's go back. Remember how I said I hate this formula? That formula sucks. Now, let's see if you guys remember anything. If you're looking for the angle, you do the... Very good. So, let's change this up now. Let's change this up. I want the inverse. So, if I'm looking for the angle theta, that would be to the inverse tangent of what? B over A. Very good. So is this formula a lot easier? Yeah. You just plug it in. We know you're looking for an angle, so you have to do the inverse. Yes. Okay, good. All right, so let's do what the angle says now. So now theta is equal to inverse tangent of B. What was my B value? -2 over A, which is 3. All right, that's what we had right there. And now, we want this in degrees. So please make sure your calculator is in degrees, not radian, because when I checked someone's last hour, they were in radian for some reason. So I don't want you guys to get it wrong for that reason. Did you get it? Yeah, okay. What'd you get?
All that.
You like Zodal.
I thought you said
Negative what? Very good. Now, you guys recall what's a negative mean? It's going backwards, right? So that means that this is my negative angle going backwards. And if we want the other angle, if we want this other angle here, what would I do to try and get at the other side? How do I get the other side there? Plus what? Not 180. 360, right? Because it's coterminal. So add 360 to this. So we would do theta equals, that's going to be 360 plus my negative 33.7, which is going to give me 133,276.3. Now, questions over that? Not bad. Questions, concerns, complaints, conspiracy theories. All right. So for this, okay, you can calculate it too, like we did. And they did all kinds of crap here for horizontal and vertical. But guess what? We're going to save that for tomorrow. So make sure you guys all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff from my merch store. Okay? Good. Hurry up. Buy stuff because I'm going broke. All right. Use the rest of the time for homework.